Hello everybody, my name is Miguel Villegas, and today I'm going to be presenting to you guys the advances in fingerprint technology and forensic science applications. So before we get started into the different technological advancements we're going to cover, it's best that we get a good foundation of what forensic science is about. So forensic science is also known as criminology or criminalistics, and it's the application of science and the scientific method into criminal and civil laws, as well as criminal investigations and crime scene investigations, right? So for some context, we have to look at a little bit of forensic history. For the last 20 years, we've seen massive advancements in technological fields within the forensic studies, right? And this has helped shape a new form of forensic science, right? We no longer see the old stereotypical detective work like Sherlock Holmes going to a crime scene and deducing from what he sees, only from what he sees, right? We know that the human eye is fallible and that human beings can rationalize, fallaciously, right? So now we actually have material and empirical evidence that could support our rationalizations. And those two things can go hand in hand and help us out and figure crime scenes out better, right? So these technological advancements are very new. As I said, it's only really been 20 years that we've seen what we have now. It's been over 35 to 40 years that we have different forms of DNA tracing, right, and fingerprint tracing, but it's only 20 years that we've actually kind of perfected the craft. And since their inception into the forensic community, they have been perfected by forensic scientists and criminologists, right? So let's go ahead and get started with DNA fingerprinting. It is the comparison of DNA and the nucleated cells of an individual with the biological traces that have been collected at the crime scene. So I leave a fingerprint at a crime scene in a crime that I committed. I'm leaving traces of my DNA through little oils and secretions from these fingerprints, right? And with these secretions is that these scientists get this information, right? So this helps in identifying the culpable individuals, me, the criminal, if I were the criminal in this case, and exclude innocent people that in a different time may have been suspected of even more if it were just based on supposition and observation, right? So other kinds of advancements that we see are alternative light photography. So if you ever watch CSI or NCIS or any form of crime show and you see forensic investigators going into a crime scene with this light that shines in a dark room, that's what this is. They also have these specialized cameras that take pictures of different parts of the crime scene that have these kinds of alternative lighting. And what they help do is identify different fluids that the human eye not necessarily isn't capable of seeing, but that could miss if you're just inspecting a given scene. It's revolutionary as well because it's very simple and non-destructive. It does not impose or just, yeah, it does not destruct the area. It does not take away any space either. It's just something that's actually handheld, right? So for instance, it identifies blood because blood has light absorbing properties. Urine, it identifies urine, saliva, and semen as well. And it's because these different fluids emit a fluorescent effect through their chemical makeup, right? So another one is facial reconstruction. So we see how facial reconstruction is so incredibly important to forensic studies because let's say we have a case of kidnapping and it's a kidnapping of a person at a given age, let's say a young age, an adolescent or a kid in some cases. If years pass by without any trace of this individual, facial reconstruction can help us see what this individual may possibly look like after time has passed, right? So forensic scientists use anthropology, right? This is considered forensic anthropology in order to facially reconstruct, you know, individual faces. So forensic anthropology in this case is applied to determine age, sex, race, ancestry, dental formula, skeletal and bone structure, as well as soft tissue. And these processes are broken down into three different phases that I'm going to go ahead and cover in more detail in these next slides. The first one is anatomic modeling. So anatomic modeling is a phase that entails gathering the significant muscle and structural bases that are provided in the anatomical guidelines. Um, the proportions, outlines, and virtual positions of the muscles and structures guide this part of the process. Right? So now the second stage is morphology. Morphology is really trying to figure out what the face looks like in regards to bone structure. So if you're looking at the eye area, this is really broken down to a few areas of the face, mostly the eye, nasal, and mandibular area. So you have your eyes, and they have to figure out how the eyes could possibly fit in the orbital bones given the skeletal structure of, let's say, a cadaver. For the nose, you have to look at the nose morphology, the width of the nasal cavity, the size of the nasal cavity, and the soft tissue, if there is on the cadaver, on the body, if there is any soft tissue. And then for the mouth, you have the construction of the teeth, how they're lined up, dental arrangement, and how this affects the shape of the face. And you also have ear morphology, and it's directed by the angular position of the ear based on the location of the jawline. This is where the mandible comes in. It's not just for the teeth and this part of the face, but also helps figure out how the ears would fit within this face, right? Now then we have facial depiction. This is the final part of the process of the phase, the final of the phases, right? So this is essentially once the face is constructed, showing it to whoever is involved in the crime, in the crime scene investigation, to see if this victim can be identified. So the depiction of the resultant face involves applying various surfaces or surface details of the skin, like texture, skin texture, colors, hairstyles, and individual effects, right? So facial detail is paramount in facial recognition because of the uniqueness of every single face of every single different individual, right? If it were not for these unique properties and qualities of each face that would be found in facial detection, faces would become void of uniqueness and indistinguishable by those who are set to identify these faces. So these were some of the different advancements that we've seen in forensic sciences over the last years. And in conclusion, these advancements are now integral to modern criminology. Because again, as mentioned before, we no longer have to rely on pure supposition and assumption and observation. Now we actually have data, material, empirical data that can help us better understand a possible crime scene or the possible way a given crime may have transpired. That's why I have the new kind of Sherlock Holmes here on the slide. We no longer need that stereotypical detective. Now we need that form of rationalization paired with these new advancements, with this new material that we have at our disposal. So again, obviously they have brought massive change to the forensic field. I thank you guys so much for being with me in this presentation, and I hope you all have a good day.